algebra students. Today's lesson is on zeros of quadratic functions. The zeros of a quadratic function are the places where the function intersects the x-axis. They are called zeros because when you are on the x-axis, the value of y is 0. They can also be called x-intercepts or roots of the equation. Up top here, you see two graphs of parabolas. The parabola is the shape of a quadratic function. Again, the zeros are the places where this parabola intersects the x-axis. So this is the x-axis, and in this parabola, there are two zeros. One here at -2, 0, and one here at +2, 0. When we label the zeros of a function, we can label them as points, or since we know that the zeros will always have a 0 in the y-axis, we write a solution bracket and we say that the zeros are -2 and 2. Again, these can also be called the roots or the x-intercepts of the equation. On your homework tonight, we're not going to do the solution bracket. You're just going to write your zeros as a number, comma, the other number. I'll know that you mean for there to be solution brackets on the outside of it. In this parabola, there's a 0 here and here. This 0 is at the point 1, 0, and this one is at the point 3, 0. So this has zeros at 1, 3. 1 is the first 0, 3 is the second 0, and we put them in a solution bracket to show it's not a point. It's not the point 1, 3, which would be up here. It's two different places where my graph crosses the x-axis. It crosses the x-axis at 1, and it crosses the x-axis at 3. Again, on your homework tonight, you're not going to do the solution bracket. You're just going to put 1, 3, and I'll know that there's a missing solution bracket there. One way to find the zeros of a quadratic function is to graph it and actually see where does the parabola intersect the x-axis. But another way is to do it mathematically. In order to find zeros of a function mathematically, we make y, or f of x, be 0, because you know that anywhere on the x-axis, your y or your f of x would be 0. So you rewrite your function as 0 equals x squared minus 49, or 0 equals -3x squared plus 12. Rewriting the functions using 0 creates an equation that we can then solve to figure out where does our parabola intersect the x-axis. One way to solve quadratic equations is with factoring. We can factor these equations and we can see what the answer is, and that will be where the parabola crosses the x-axis. So for example, in this top one, where it started out as y equals x squared minus 49, and we turned it into 0 equals x squared minus 49. We can factor that pretty easily because it's a sum and difference pattern. Remember, a sum and difference pattern is where you have two terms. The first one's squared, and there's a subtraction sign between them. When it's a sum and difference pattern, you put two parentheses, and you see what times itself gives us x squared. Well, x squared is x times x. And what number times itself gives us 49? That would be 7 times 7. 7 times 7 is 49. And then you make it a sum and a difference. So if I wanted to factor x squared minus 49, it would be the quantity x plus 7 times the quantity x minus 7. That would be my factored form. So this equation can be rewritten as 0 equals the quantity x plus 7 times the quantity x minus 7. Then we solve this. So this is 0 equals x plus 7, and this is 0 equals x minus 7. Subtracting 7 on both sides, we get that -7 is one value of x. Adding 7 on both sides, we get that 7 is the other value of x. that means that this function crosses the x-axis at -7 and 7. So my zeros are at -7 and at 7. If I were actually going to graph this, that means that this point right here, where it crosses the x-axis, would be -7, 0. And this point right here, where it crosses the x-axis, would be 7, 0. Let's go ahead and look at our second example. I'm going to draw a line to make it clear that we're now on our second problem. If we look here, it started out as f of x equals -3x squared plus 7. I'm sorry, plus 12. I'm still reading up here. So f of x equals -3x squared plus 12. I can replace f of x with 0, since on the x-axis my y is always going to be 0, and I get 0 equals -3x squared plus 12. Now again, I can factor this to solve it. When I'm factoring this, the first thing I should do is look and see if there's a common factor. These two numbers do have a common factor. They can both be divided by -3. So I'm going to rewrite this. I'm going to put -3 outside the parentheses. -3 times x squared would give me -3x squared. And -3 times -4 would give me positive 12. So after I factor out my common factor, my problem is 0 equals -3 times the quantity x squared minus 4. Now I can see that inside the parentheses I have a sum and difference pattern. It's a sum and difference pattern because there's two terms. The first term is squared, and there's subtraction separating them. So I can factor this further. The -3 can just come down, as can the 0. I'm looking for two things that multiply to give me x squared, and that would be x and x. And two things that multiply to give me 4, that would be 2 and 2. And then I make it sum and difference. So now my factored form of this is 0 equals -3 times the quantity x plus 2 times the quantity x minus 2. Now all I have to do is solve this. So if I solve this, I can make it so that we have this part of it equals 0, so 0 equals x plus 2. I can have this part equal 0, so 0 equals x minus 2, and I can solve that. I subtract 2 over here. I get -2 equals x. I add 2 here. I get that positive 2 is x. So then my zeros are going to be at -2 and positive 2. If I graphed this problem, there would be a 0 here at -2, 0, and a 0 here at +2, 0. Tomorrow we'll go into whether you graph your parabola like a U or like a curve and what determines that. So don't worry about that today. Today we're just talking about the zeros. Let's look at one more example. So our last example is going to be this. G of x equals 36x squared minus 25. Again, I'm looking for the zeros. My first step is going to be replacing g of x with a 0. So this is now 0 equals 36x squared minus 25. My second step is looking for a common factor. There's actually no common factor of 36 and 25. There's nothing that they can both be divided by. So next, I see if I can factor this, and this uses a sum and difference pattern. You can tell because there's two terms with squared in the first term and subtraction between them. So we can factor this using the sum and difference pattern. We're looking for two things that multiply to give us 36x squared, and that'd be 6x and 6x, because 6 times 6 is 36, and x times x is x squared. Then two things that give us 25, and that would be 5 and 5. It's going to be a sum and a difference. So in factored form, this is 0 equals 6x plus 5, the quantity of 6x plus 5, times the quantity 6x minus 5. Now I solve these. So this is 6x plus 5. 0 equals that. And this one, 0 equals 6x minus 5. I go ahead and subtract 5 over here from both sides. And I get that negative 5 equals 6x. I divide by 6. And I get negative 5/6 is one of my zeros. For the other one, I'm going to add 5. And we get that 5 equals 6x. Again, I'm going to divide by 6. And I'm going to get that 5/6 equals x. So my two zeros here are going to be at negative 5/6 and positive 5/6. So if I graphed this problem, we'd have our parabola shape. My zeros would be here and here. And this one would be negative 5/6, 0. And this one would be positive 5/6, 0. So that's how you find the zero of a quadratic function. If you have any questions, please feel free to email me. Have a good day.